This is an interesting paper from 2009, and this group of people just did some computer modeling on what would have happened if CFCs had not been regulated, if we had continued as usual using CFCs, if the Montreal Protocol hadn't been signed. And this is the link to the article. So they model they set out to predict what would have been the ozone levels if nothing had been done. And they use a particular climate model. They use, information on solar energy, chemistry, temperature, winds, etc. And they call this scenario the world avoided, what we have avoided. And they run a simulation that took months of computer time to process what would have happened if the levels of CFCs released in the atmosphere would have increased by 3% per year. And that was roughly the rate before they were regulated by the Montreal Protocol. And they ran a simulation that covered between 1975 and 2065. How would the world have looked in 2065 if we had continued if CFCs hadn't been banned? And this is what they came up with. They came up that by 2020, 17 of the global ozone layer would have been destroyed. So this is how, the reference in the past, they took 1980 as the reference, how things looked before the Montreal Protocol. And if this had continued by 2020, 17% of all the global ozone would have been destroyed. And we would have had both a hole in the Arctic and the Antarctic. This would be the corresponding how the 1980 levels of ozone looked over the Antarctic, and how the 2020 in this world avoided scenario would have looked like. So there will be not only an ozone hole forming of the Antarctic, but a corresponding one forming over the Arctic. And by the year 2040, they predicted that the ozone hole, which is considered as any concentration of ozone below the 220 Dobson units, would be global. So it would not be only in the poles. It would have formed all over the world. So what about now? Well, the ozone hole peaked in the 2000s, and since then it was the largest ozone hole recorded. Since then, the levels of chlorine and bromine atoms, let's not forget halons too, have fallen for about 16%, because although there are still many around in the atmosphere, they are not being produced anymore, they are not being released anymore. The level of ozone depleting substances increased up to the 2000 and has slowly decreased since then. But it's still high enough. There are still enough CFCs in the atmosphere, and they will be for a very long time, to produce a significant seasonal effect on the ozone layer, to produce that very noticeable ozone hole, in this case over the Antarctic region. The size of the hole is also widely affected by meteorological factors, by the polar winds, the formation with stratospheric clouds, and that complicates detecting a long-term trend. For example, 2019, because of the particular weather conditions in the South Pole, hamper the formation of polar stratospheric clouds, the ozone hole was the smallest ever recorded since the early 80s, 16.5 million square kilometers. But in recent years, with more normal weather patterns for what it is the spring time in the South Pole, the ozone has increased slightly. In a typical year with typical weather conditions in the South Pole, the ozone hole grows to approximately 20 million square kilometers. And again, remember, it is not a hole. It's not that there is no ozone. It's that the concentration of ozone is very small. It's defined as less than 220 Dobson units. So this is it from me about the stratospheric chemistry and specifically the chemistry of ozone. As usual, if you have any questions, please email me or post. I would really encourage you to post in the discussion board for the module, so we have a general discussion about these issues. And as a reminder, I am subscribed to those forums, the assessment one and the one for the module, so I will get a notification when you post. I hope it was useful, and thank you for watching.